Electrode potential. Electrode potential is the relative tendency of the electrodes to undergo the oxidation or reduction. So we can say electrode potential is the tendency of a particular metal to lose electron or to gain the electron. We know when you connect to the two electrodes, for example, we have here the zinc electrode, you connect it with the copper electrode. So what we find once you connect to the two electrodes, electrons start flowing from the zinc to the copper, right? And you get an electrochemical cell of the 1.1 volts. And in this system here, you can just see when the the electrons flow from the zinc towards the copper, that means the zinc undergoes the oxidation and the copper undergoes reduction. So zinc loses electrons. Actually over here, the zinc metal, in this case the zinc metal actually dissolves into the zinc ions, it dissociates into the zinc ions, and those ions go into the solution, and the electrons, they start flowing through this wire towards the copper electrode. And the copper electrode, in the copper electrode, the copper ions then gain the two electrons. That means the copper ions undergo reduction, they gain the electron. So copper ion gains the electrons and forms the metallic copper. So that means when you compare the two electrodes, the zinc with the copper, we can say that zinc has a high tendency to lose the electron and the copper has a higher tendency to gain the electron. So that means zinc has the high, I can say that zinc has the high oxidation potential, because the tendency to lose the electron is called oxidation potential and the tendency to gain the electron is called reduction potential. So I can say zinc has a very high tendency to lose electron, which means that zinc has high tendency to high oxidation potential. And the copper, which gains the electrons over here, means that it has high tendency to gain electron, which means that it has a high reduction potential. Okay, so copper has a very high reduction potential because tendency to lose electron is called oxidation potential and tendency to gain the electron is called reduction potential. So electrode potential is basically of two types, oxidation potential and reduction potential. In general, we say that electrode potential is a tendency to lose or gain the electron, right? And the tendency of a metal to lose electron is called oxidation potential and the tendency to gain the electron is called reduction potential. Now, as you compare the zinc with the copper, we find that the zinc has a higher tendency to lose electrons, so I can say it has a high oxidation potential, while as copper has high tendency to gain the electron, means it has a high reduction potential. Now the question is, how do we measure it? How can we measure which has high oxidation potential and which has high reduction potential? So basically, to measure that electrode potential, to have some quantitative value for the electrode potential of a particular electrode, we actually have to take a reference electrode, right? So we take a reference electrode and we connect the different electrodes with that reference electrode, and from that reference electrode we can now compare the electrode potentials. We can calculate the electrode potentials, and for that I have a separate video. So we have a different different video on this, how to find the value of the electrode potential of a particular electrode by connecting it with the reference electrode. Now in this case, in this particular example, if you can see here, something 1.1 volt, right? Basically this is the galvanic cell that you get when you connect a zinc rod with the copper rod, and that galvanic cell has a 1.1 volts, and this voltage here you get it from the oxidation potential of the zinc and the reduction potential of the the copper, because here the zinc undergoes oxidation and the copper undergoes reduction here. Now, what are the factors on which this electrode potential will depend? There are three main important factors on which the electrode potential depends. Suppose we have here the zinc rod and we connect it in a solution of the zinc sulfate, right? So we have here a solution of a zinc zinc sulfate solution here. Now, the electrode potential of an electrode depends on the nature of electrode. You know that copper is different than the zinc. So the nature of electrode is one factor, right? So the first factor is the nature of electrode. The copper we know is different than the zinc. So they will have different electrode potentials. The next point is the concentration of the ions in the solution. That means the concentration of the solution here. You know, suppose you when you insert a zinc rod in the zinc sulfate solution, and the zinc sulfate has a 1 molar solution, right? We have a 1 molar solution. Now this electrode will have some electrode potential, the zinc has some electrode potential, but if you change the concentration of the solution, that means suppose now we have a zinc rod in a 2 molar solution. So in a 2 molar solution, you know, you dip a zinc rod in a 2 molar zinc sulfate solution. So in a 2 molar zinc sulfate solution, you will have a different electrode potential. So that means changing the concentration of the ions will also change the electrode potential. And the third factor is the temperature. You know, temperature is one more important factor. So if you increase the temperature or you decrease the temperature, the electrode potential of a particular electrode also changes. So that means, for example, we have a zinc rod in a zinc sulfate solution. The concentration, let's say, is 1 molar, and if you take this, you know, this electrode here at 25 degrees Celsius and at 50 degrees Celsius, right? So at the two different temperatures, this particular electrode will have a different electrode potential. So by changing the temperature, the electrode potential also changes. The quantitative effect, say this quantitative effect of the concentration and the temperature on the electrode potential, that will be studied in the Nernst equation. You know, we have a next topic which is actually a Nernst equation, right? The Nernst equation is there, and this equation tells us the quantitative effect of the concentration and the temperature on the electrode potential of an electrode. So we'll discuss it there, you know, how this electrode potential will change, whether it will increase or decrease by increasing or decreasing the concentration and the temperature. So which means that if you take an electrode under the the standard conditions, the standard condition means the 1 molar concentration. So if you take a particular metal, suppose we have a metal rod, and you insert a metal rod in a solution containing the metal ions, and let's suppose the concentration here is 1 molar and the temperature is 25 degrees Celsius. Now, under these conditions, when you take the concentration of the ions 1 molar and temperature 25 degrees Celsius, under this condition, the electrode potential of the electrode will be called as standard electrode potential. So standard electrode potential is the electrode potential of an electrode under the standard conditions, means 1 molar concentration and the temperature is 25 degrees Celsius. So in the next video, we will see how do we determine the electrode potential by taking a reference electrode, right? And we know the reference electrode is the hydrogen electrode. Thanks for watching the video. Bye for now.